This short video will demonstrate how to run horizontal well correlation in time, a new feature introduced in HampsonRussell 10.3. The well path is defined by 4 points: the anchor point, kickoff point, heel, and finally toe. Any stretching that is required happens between the anchor and the kickoff point, and the heel point can then be adjusted by the user up or down and measured depth. The purpose of this is to preserve the shape of the curved section. And finally, under user control, the toe can be adjusted up or down. In order to display an initial well path within a time seismic section, it's necessary to have a sonic log, a P-wave log. This could be copied from a nearby vertical well, or in this case, it's simply an Excel table that's been imported as a sonic log with points every 10 meters and a constant value of 3,000 meters per second. It's also necessary to have loaded any deviated geometry, in this case measured depth, dip and azimuth, and the path of our well is shown on this map. We'll go now to a live run of the software. We start in the wells window, showing on the left our constant P-wave sonic log, and on the right our horizontal well path. The basis of this interpretation is that the interpreter, or the geophysicist, knows where in the seismic section the well path is supposed to lie, and so this process is done solely by eye. There's a new icon to start the process, which we'll initiate, and we'll choose our volume to correlate with, in this case an impedance volume. And we begin by setting an anchor point, the initial point from which any stretching will be done, and we then also choose a kickoff point, the end point from which any stretching will be done, so that again we preserve the curved section of the well. We'll go next, and a light green box opens which activates the stretching part of the operation, and so now simply by using the mouse we can move the well path. We'll just hesitate at this stage to change the well color and thickness so it's very obvious, to move the well path to wherever the interpreter or geophysicist believes it should be. We then identify the heel point, which we can move or the software will choose for us automatically. And finally, we can shift the toe up or down. In this case, we'll choose this point here, and we'll apply the correction. We'll give the correlated log a name, and that completes the initial part of horizontal well correlation. To have correlated a well is useful, but what's more useful is to be able to extract attributes from seismic volumes along the path of that well. And we can do this in an existing process called export composite trace. So the export composite trace allows us to choose any number of seismic volumes and any number of wells, and to export the values along the well path back to the well project data. We'll return now to the PowerPoint just to show. Here we have the path of a correlated horizontal well. We have inserted in color the impedances that were extracted from that volume, and on the left we can see, extracted from the wells tab, a colored version of the impedance along the path of the well. You'll notice that it becomes blocky towards the end of the log, and that's because as we're extracting that well, we are stepping from trace to trace within the seismic volume, each in this case 25 meters, hence the rather blocky nature deeper in the curve. That completes this short demonstration. Thank you.